Look at the last question of question 24. It's part D, and it says explain in terms of the Lorentz factor why an observer can ignore relativistic effects for an object which is moving with a velocity much less than c. So the Lorentz factor, just to remind ourselves, is the gamma factor, and it's given by 1 over the square root of 1 minus v upon c all squared. And so the question is, what happens to this Lorentz factor whenever the velocity is much less than c? Well, if v is very small compared to c, this number itself will get very close to 0. So effectively what you've got is 1 minus 0, and 1 minus 0 is 0, so effectively at the bottom you've got the square root of 1, which is equal to 1, and it's 1 over 1, therefore the gamma factor is effectively equal to 1 when the velocity is much less than the speed of light. And so if the gamma factor is much less is equal to 1, remember that the contracted length is equal to the rest length divided by gamma. And if gamma is equal to 1, then our contracted length is effectively the same as our rest length. And so therefore there's no noticeable change in the length or indeed the time observed by an observer relative to the moving object.